This is the Lightning Junkies podcast with your host, Chaz. On this week's episode of the podcast, we have Giacomo Zucco, and we're talking about RGB and client-side validation. So I recorded an episode with Giacomo in 2019. We did this live at the Lightning Conference in Berlin in the descent truck outside of the conference with a lot of loud music playing. So obviously it was some of the worst audio I ever recorded for the podcast, and I definitely believe that Giacomo and RGB deserved a little bit more attention and a little bit more clarity in order to ensure you didn't have to endure terrible audio to get there. Most of this episode talks about RGB and how it might be used on top of the Lightning Network and various other topics, including OmniBolt and how it might compare to RGB. Just a quick reminder that you can support the podcast on Breeze by searching Lightning Junkies. You can also support us by going to lightningjunkies.net/support, as well as store.lightningjunkies.net, where you can pick up merch. We believe that this is a value for value transaction, just like Adam Curry has laid out most recently. All that sounds good to me, so let's go ahead and jump into this episode. I would like to go ahead and welcome Giacomo to the Lightning Junkies podcast. How are you doing today, Giacomo?
Fine, thank you. How are you?
I'm doing pretty good. As people that listen to the podcast might know, the last time we had you on was a kind of experimental podcast where I tried to record live at the Lightning Conference in Berlin in 2019, I believe. And that was okay, but it just created very bad audio. And I was very much interested in getting, RGB and, the other stuff that you're working on more out there and more well known. So I thought it was worth the time to bring you back on.
Yeah, this is very bad news for me because with bad audio, I have a great plausible deniability if I say something stupid about technology. So I can make promises, I can create expectation, and nobody can keep me accountable because audio was bad. So maybe I was just misunderstood. This time I will have to be more cautious.
Yes, we'll definitely hold your feet to the fire here. And if you talk too much shit, we'll call you on it. But I don't anticipate that, to be honest. I think, honestly, you're one of the more intellectually honest people on Twitter and elsewhere, possibly. Like, I think you and I disagree on a great many topics that I'm not going to mention here because that's not really the venue for it. But I definitely find you to be very honest in what you do and do not know and what you'll claim. So you're pretty high in my books in that regard.
Thanks. I appreciate it.
Let's go ahead and jump into RGB. My understanding of RGB essentially is it's like a layer 3 that could live, or I guess technically a layer 2 possibly, that could live directly on Bitcoin or it could live on top of Lightning. Is that right?
It is right. In a way, at least in my initial conception, then during the conversation, we will basically decouple a little bit the initial design from what we have now and what we can have in practice in reasonable time. So there is implementation and there is theory. In theory, my idea was that even the part of RGB that doesn't use Lightning Network channels in order to transmit off-chain some kind of asset would use anyway Lightning Network as an infrastructure to move stuff around. What I mean is this. The main concept of RGB is the idea of Peter Todd, which is client-side validation. So the idea of Peter Todd is that it's silly, it's wasteful, it's not optimal, that the miners in global consensus will understand and parse and validate the syntax of the transactions themselves. The miners should just do proof of publication, which is ensure that you cannot double spend the same UTXO, and the validity of the spend itself should just travel with the people passing down the road the chain of the validities of the previous transaction. So this idea by Peter is an idea that some obvious advantages. The advantages are a little bit of scalability because basically burning one single UTXO, you can prove the non-double spended transaction of hundreds or thousands of different assets from different people. So there is this kind of scalability that Peter calls proof marshal. And there's also a great privacy advantage because, of course, if you think about this kind of model, the only guy that knows about the history of the asset is the guy receiving the asset. Everybody around would not know about any of the previous steps of the asset transfer. And if you do some kind of cryptographic magic, you can also obfuscate the past pretty well. So these are the obvious advantages of client-side validation design, but there are some disadvantages, and these are basically that the receiver, unlike in base layer Bitcoin, must always be online, or somebody else must be online for them, because they have to receive off-chain all the proof of validity of the asset transfer, all the chain of past transfers since the issuance. So there is this necessity to be online. And then there is a necessity to store the data, the off-chain data, because with your seed alone that is moving the UTXOs, you cannot recover the asset. You need to store everything. And if you lose it, if you lose this off-chain data, you lose the asset. So these are pretty bad trade-offs to have in a system. So Peter's idea back in 2016, 2015 was considered impractical. But then the reason that I was excited about RGB in connection to Lightning is that Lightning Network, for other reasons, has exactly, or not exactly, but kind of the same trade-offs. So in order to receive a Lightning transaction, you need to be online, or you need somebody online for you, like a partially trusted third party, a watchtower or something. And then in order to keep your funds, you need to back up separately from your seed. You need to back up all the channel states separately. So my idea was, let's take the old idea by Peter and let's merge it with Lightning, and let's reuse everything Lightning does for in order to be online and receive stuff, and in order to back up stuff. So my idea was, let's use Lightning as infrastructure to send off-chain proofs as a payload, a little bit like, the projects that are using Lightning as messaging system, like WhatsApp or Sphinx chat and stuff like that. So use the same idea, but instead of passing over messages like in chats, you pass over the off-chain proofs that the client-side validation model used. So all this big introduction is just to say that even if you don't use a payment channel with RGB assets locked in a channel, you still use, at least in my idea, Lightning Network as the base for RGB, because Lightning Network will be used to transmit around, and the same kind of stuff that people will use to back up Lightning Network channels will also be used to back up RGB assets. So that was the theory. As we will see in practice, things turned out to be a little bit more complicated.
Before we jump into that, I think I want to explore some of the philosophy of why you might do an RGB or something similar to this. Years back, I'm sure you're familiar with the idea that eventually Bitcoin's going to absorb all technology into it, in some sense. So Ethereum has, the EVM and smart contracts and the way that they do it. Is the general idea of RGB to kind of create Ethereum on top of Bitcoin in a certain sense? Not to go the rootstock path, but maybe take a different path? Is that maybe kind of where that the general idea came from, aside from the technology aspect?
It didn't start like that. It just started for two competing reasons. One reason was basically clients asking me what kind of good standard could be used to do permissionless asset issuance and transfer, or kind of permissionless, in a Bitcoin compatible and Bitcoin inspired way. So I didn't have a good answer to this, because all the previous standards like Omni, we will talk about Omni and possibly OmniBolt, we will talk about Counterparty, colored coins, and then shitcoin chains like ERC20, etc. All these alternatives seemed very bad to me and also to the smart people I was asking about this client job. So all the de facto standards in this very very niche market were pretty bad, and I didn't have a good standard alternative to propose. And then there was this idea by Peter Todd, the client-side validation model, that in my mind was fitting perfectly with Lightning Network, was basically merging with Lightning Network in a very good way. And so I had this desire to do an experiment on this design, regardless of the use cases. So there were a few use cases that were basically just assets, so normal assets. Even in Ethereum, you hear a lot of talk about smart contracts, but 99 point something percent of smart contracts just do one thing. They issue some kind of asset, which can be sent without double spending, because that's what the Ethereum blockchain does, and that's basically all. There are a few more advanced contracts that may be used to swap stuff, like in the new DeFi craze, the new DeFi hype. There may be some atomic swap. There may be some Oracle doing something like in MakerDAO, etc. But these are really exception. Most so-called contracts just do issuance and transfer of one asset. So I was focusing on that. But since the design that we came up with was also in theory possible to use for a state machine, a generic state machine that could also do more stuff, most of the other engineers working on RGB, and especially Maxim Orlovsky, that was with me at the Lightning conference when we met talking about this, and he was presenting with me, and he and other people working on the project were especially fascinated and captured by these possibilities. So there have been a lot of efforts to generalize the simple asset based idea into something which is more smart contract-ish. I mean, I'm still skeptical about the real world use case for this kind of complicated variances. In my opinion, the best way still now to do smart contracts is just to have an oracle and then some kind of multi-sig where the oracle can set the threshold, and the oracle can use HSMs or complex cryptography or in order to blind stuff, or other kind of trust models in order to be difficult to shut down or difficult to or to make exit scams difficult or stuff like that. But the idea to decentralize entire state evolutions is possible, and it's challenging for developers to try to actually do what Ethereum claims to do for real this time. But personally, I'm still super skeptical about real world use cases. So for me, it will be enough to just see a couple of reasonable enough use cases that are basically Tether, which for me is a great way to buy Bitcoin, avoiding KYC and AML. It's the only reason I like the existence of Tether, which is a provisional tool. Of course, it cannot last forever for the same reason that e-gold didn't last forever. It's centralized, so eventually it can be stopped. But it's a good tool to go around some kind of limitation in liquidity between fiat and Bitcoin. And the second use case, that when I was talking about that in the Lightning conference, or even before in Building on Bitcoin Lisbon, the second use case is digital collectibles. And back then, it was not a huge hype like NFTs, everybody talking about NFTs. Back then, it was just rare papers, basically. But I think this is a reasonable enough niche, not very important use case. It's irrelevant if you compare it with Bitcoin. Bitcoin is something serious, something world changing. Digital collectibles can be legit. They can be okay. They can be not bad if realized. And these two use cases would be enough for me in order to prove the concept. And the concept itself can be great if eventually applied to Bitcoin itself. We don't know how. In order to use this kind of design for Bitcoin, you will need the same kind of sidechain concept of two-way peg. So if you can issue an RGB asset which corresponds to a Bitcoin, which is easy, you just do like a proof of burn, and you can also destroy this RGB asset, unlocking an on-chain Bitcoin, which is very hard, and I have not the slightest idea how to do that without trust, without federations, then you can use the client-side validation model on Bitcoin itself. And that will be indeed very, very good for me from the experimentation point of view. It will merge fine, it will interact and merge with many other kind of ideas like all the ideas that Ruben Thompson is talking about, space chains and soft chains and state chains and all that stuff.
Just to kind of ask about that last point really fast. Would that imply that RGB would either work better with any prev out slash L2, because any prev out would get us L2? Would RGB work better with that, essentially?
Not itself, but a specific, we could come closer to a specific RGB use case because people often tells me about RGB. This is a cool way to create assets, but we don't need assets. We already have Satoshis and that's enough. And I kind of agree. Again, with the exception of rare papers and CryptoKitties, they're legit, even if not very useful, but they may be legit. But the point is that you already have Satoshis. But the answer, the real long-term cool answer to that will be, yes, but I can use RGB as a way to represent Satoshis off-chain in a client-side validation model, which is even in a way more powerful than Lightning itself, and also in another way compatible with Lightning itself. So so this is the idea, and having this kind of changes will probably make this kind of end result closer, but not there yet. Even if you have these various modifications, which are basically reedition of Sigeshno input idea for L2, you can create better stuff like state chains, but it's still not trustless two-way pegging. So it's still not really moving Bitcoin out and then Bitcoin in a way which is fully decentralized and trustless. That really doesn't exist yet. So that will help, but it's still something purely speculative.
I did hear something what you said there that I found kind of interesting. Over the time that I've had the podcast, something I've heard come up multiple times is the idea that cheap fees on top of Lightning Network aren't going to last for forever because, fees on Bitcoin itself will raise and Lightning Network fees kind of lag behind that, but are kind of connected or correlated. Do you see like RGB being able to be a layer 3 eventually that most people will actually transact on? And layer 1 and layer 2 will just be these more expensive layers that most people will not touch? Or am I going too far with that?
I think you may be going too far, since even if Lightning Network fees become high, which is entirely possible, they will not become high in the very same way of on-chain base layer fees, meaning that they are based on very different kind of scarce resources. Right now, Lightning fees are not really optimized for resources that the routers are expending, because it's still super young and nobody's actually paying huge fees, so nobody cares. This is similar to the situation for on-chain fees in maybe in 2011 and 2012, the beginning of 2012. Miners didn't really optimize for dimension or SIGOP cycles or whatever, because they didn't care that there was lots of supply of block space and very little demand, so nobody cared. But then they started to optimize, and now when a miner decides to take or not take your transaction, they will automatically optimize for space consumed by your transaction, but also for validation CPU power basically consumed by your transaction, and they will make their trade-offs and they will decide. In the same way, right now, if you route on Lightning, the router will probably just ask you some kind of fixed fee. Maybe some smart router will ask you one fixed fee and one fee that will be proportional to the amount, but that will be basically all. But in the future, the more this kind of activity will become expensive for transactors and remunerative for routers and competitive, among routers, the more routers will tend to optimize, and this I think will end up in a fee situation which will be very different, radically different, and even complementary to on-chain. What I mean is that on-chain, basically, you have fixed costs. You don't pay for liquidity. So on-chain will always be great for huge payments because you don't pay for liquidity. You just pay for space consumed on the block to describe your transaction, but not you don't pay more to send more money. You can send $2 billion, and you can, in theory, and you can say let's say 2 millions for now, and you can consume fairly little block space with this. On the other hand, on Lightning, the real cost that the router is bearing is a cost of liquidity, getting his channels out of balance. So it's reasonable to think that small payments will always be fairly cheap on Lightning because you are not moving much liquidity. So the router will not sacrifice much in order to let you route. But if you move a huge amount of bitcoins, of satoshis, then the router will have to move a lot of liquidity, and they will have to go out of balance, and then they will have to rebalance with some kind of strategy like competing transaction in the other direction, or submarine swaps, loops, and whatever. So they will need to do something in order to rebalance. If you keep moving huge amounts in the same direction, routers will just be depleted of their balance situation. So it will be probably realistic to expect in the future routers that will let you pay not just based on the amount of liquidity that you are asking for, but also based on the direction, and based on the fact that the direction is going to rebalance them. So if you are going to rebalance, you will pay less, or even zero, or even in some kind of science fiction scenarios, even negative, you could be paid to write through me because you are rebalancing me. This is very difficult to do because this messes up the path finding, the path discovery algorithm, because they have positive weights, not negative weights. But anyway, in theory, I could give you negative fees if you route through me rebalancing me, and I will ask you positive fees if you route through me pushing me out of balance. And the more you push me out of balance, close to the limit of the channel, the more I will exponentially basically ask you to pay. So if I'm correct about this, and I think I am, I imagine two fee distributions that will be completely different. In layer one, there will be basically a lot of people sending huge transactions in terms of liquidity, in terms of money, but with small block space footprint. And in Lightning Network, you will see small liquidity transaction moving low liquidity, because if you go on high liquidity, you will basically have to pay more. And if these two kind of fee markets manage to keep some kind of overlap, you don't need much alternatives. You can use alternatives like RGB and whatever, but you don't need many alternatives, because if your payment is big, then you have no cost in going on chain, because if your payment is big compared to the typical on-chain fee, then it really doesn't matter if you are spending $50 on chain if you're sending 2 millions. But if your payment is big, again, you cannot use Lightning, because the Lightning fees will be really, really high. But if your payment is very, very small, then there is no possibility to go on chain, because your on-chain fees will be higher than your payment. But there is, and there will always be the possibility to go on Lightning, because the liquidity that you will ask for will be by definition small, because your payment is small. Basically, the only thing that we want is an overlap between this fee distribution, in which let me imagine we end up in a future where on-chain fees are $100, and basically where the typical affordable Lightning Network transactions are can go as high as let's say $1,000. If that's the situation, then every time you pay $1,000 or more, you will just go on chain and you will pay 1%, and you will be, or actually that will be 10%. I exaggerated. Let's say $10,000 on Lightning. You pay 1% and you are kind of happy. And if you pay less than $10,000, then you can go reasonably on Lightning without paying too much. All that said, of course, orthogonal strategies to increment scalability can make the situation even better, but not just RGB. For example, if we have L2, we can have multi-party channels. A multi-party channel can just take down the cost to open and close a channel on chain. We can have channel factories. If we have cross-input signature aggregation, we can basically incentivize people to coin join and create channels together, multi-party channels together. So there is a lot of stuff that can happen. One of the things that could happen is client-side validation idea, increasing a little bit the scalability, because right now you can basically use one Bitcoin UTXO spending, one Bitcoin's transaction to send not one RGB transaction, but to send, in theory, hundreds of different assets to thousands of different people. So the amount of stuff that you can move on RGB, even without creating RGB channels, is potentially very, very high. Of course, there is a lot of complication in reality.
I want to take a step back and kind of go over some of the alternatives that could live on top of Bitcoin to roughly accomplish the same thing. We did go over Counterparty on our previous conversation, but let's just kind of briefly go over that. In 2014, 2015, roughly, there was Counterparty, which allowed you to have, various assets that would, kind of live on top of Bitcoin. I think they used the op return to deploy their payload on the blockchain, et cetera, et cetera. It had a lot of downsides. It was really slow. You had to wait 10 minutes before you even saw your transaction. And that's when blocks were never full. How would you compare RGB to Counterparty in that sense? Obviously not on Lightning.
Yeah, so basically the main difference is there are, I would say, even three main difference. The first is scalability. As you said, when you use Counterparty, you have to write inside Bitcoin transaction in the global consensus. So there are Bitcoin transactions on-chain Bitcoin transactions are things that are validated and stored and downloaded by everybody forever. So they are parts of global consensus. Everybody in 2070 will have to download and validate and possibly even store if they are not pruning. But somebody has to store, otherwise nobody else can download it anymore. And also you have to you cannot prune when you want to rescan and stuff like that. So everybody will have to download, validate, and possibly store your transaction that you are doing now. So this is bad enough for Bitcoin, but this is even worse for some kind of on-top layer that is, let's say, parasitical to Bitcoin in a way, because basically you're competing with Bitcoin users for this very scarce resource. There was a fight between Counterparty developers and some Bitcoin developers because Bitcoin developers wanted to restrict the use of op return because it was behaving like a tragedy of the commons because people were exploiting it. But then the Counterparty developers were actually fighting to keep it or even increase it because they need more in order to do more stuff in a more flexible way. And this is ultimately, regardless of who was right or not, this is a inherent conflict in models like Counterparty. You're using the global consensus, which is already difficult to use for Bitcoin, for some kind of on-top application. And you need to use that because all the information, all the logics, the transaction logic of Counterparty needs to be stored some way. And since it's not a client-side validation model like RGB, since it's not sent from the sender to the receiver, it has to be stored in the global consensus. It has to basically live on top of the already existing problems of local consensus. But the scalability problem of Counterparty are even worse than the ones of of vanilla Bitcoin, because, for example, with vanilla Bitcoin, you can do is not a good thing, is not a great solution, is a dangerous solution, but at least you can do what is called improperly SPV. So you can, if you can assume that the miners are enforcing Bitcoin rules, you can just check the presence of a transaction inside the Merkle tree of a block instead of validating all the previous history. So you can do stuff like hardware wallets easier. You can do basically lightweight nodes with this pseudo SPV strategy. But with Counterparty, you can't, because you cannot assume that if a Counterparty transaction was inside a block, then the miners then the block was valid in Counterparty terms. It was only valid in Bitcoin terms, but miners are not enforcing Counterparty rules. So there is a huge problem, because you cannot leverage this kind of not very good, from the security point of view, strategies like SPV. So the first point is scalability. Bitcoin scalability on chain is bad, but Counterparty scalability is even worse and problematic. Then there is privacy. As we know, Bitcoin's privacy and fungibility on chain are pretty bad if you don't use the right tools, especially because there is this kind of global consensus. Everybody will download everybody else's transactions forever. So there is a problem of everybody knows everything. If you think about Counterparty, then you have the same problem plus an even smaller anonymity set, because when you're using special assets, special issued assets, special contracts, then by definition, your anonymity set to hide Counterparty USD Tether, assuming they exist, they actually exist on Omni, but which is basically the same thing. Then you have to assume an even lower anonymity set with the same kind of fungibility problem and of privacy problems. And the third problem was that in order to make this kind of smart contract stuff work, they needed to have a native asset. So Omni had this Omni coin, the master coin that then became Omni coin, and Counterparty had XCP. While Omni decided to go in the scammy direction of the ICO, so they did a Mastercoin ICO, they basically printed money, selling it to people. Counterparty decided not to do that. They did like a temporary proof of burn window, which was, from the ethical point of view, I appreciated that. It was remarkable because they didn't make any money out of it. But ultimately, the incentives are screwed up anyway, because this XCP basically will go down into inexistence, and as any altcoin eventually will. And so it basically destroys the usability of this native coin, because the native coin will eventually be outcompeted by Bitcoin for monetary reasons. So I would say the three levels of superiority of RGB over Counterparty, but it's pretty much the same with Omni, is first better scalability because client side, while Counterparty has worse scalability than Bitcoin itself, and better privacy than Bitcoin, while Counterparty has a worse privacy than Bitcoin itself, and no scam coin needed, because you don't need to create an RGB coin in order to do stuff. So it's better in these regards.
So we can kind of skip over Omni there, since you kind of covered it pretty well. Let's move on to something I think is a little bit more comparable, a little bit more modern, I guess we could call it, OmniBolt. I'll admit that I haven't done a super deep dive on it. Are you kind of knowledgeable of OmniBolt and how it works at the moment?
A little bit, because some of the projects, I cannot go into details because some of these things are still stealth or whatever. But some of the projects that we're thinking about using RGB are also evaluating to use OmniBolt. So in a way, they are like competitive designs. They can coexist, but in the long term, it doesn't make sense if they solve the same problem. So even if it's not competition between companies, I don't make money if somebody uses RGB over OmniBolt. So it's not competition in that sense, or the opposite, but it's like more an intellectual competition in a way. So Omni itself, the old Omni, I would say compares to RGB in the same way of Counterparty, just worse because the coin, instead of being a proof of burn, was actually a very scammy ICO, and that's why Omni started with another name, and that there was a scandal, and that they rebranded. At this point, people working on Omni right now, I would not consider them associated in any form to the initial scammy ICO. The reason people are working on Omni right now is basically one of the few useful tokens in the history of tokens, which is USD Tether, was issued on Omni. So that was the whole reason to keep that old protocol alive, is that Counterparty was used for collectibles like rare papers, and Omni was used for Tether. Now Tether gets used on basically everything, on Omni still, but also on Liquid, but also on shitcoins, but also everywhere. So the strategy of Tether is just agnostic, not because they don't appreciate Bitcoin's network effects or technical superiority, but because they reasonably don't care. They just need to transfer a property title in a way that can be claimed to be decentralized and not dependent on the issuer itself for basically legal reasons and legal arbitrage reasons. So they have to claim that they're using open decentralized protocols instead of their own database. And they can use whatever, like Binance Chain, DentaCoin. I don't think they're using DentaCoin, but they could. They can use whatever. But they did decide to start with Omni at the beginning, just because they wanted to stay more Bitcoin centric. I don't know why they choose Omni over Counterparty, but I think that Omni survived so long because of that. So now people are working on Omni because they are working basically on Tether, which is the huge use case, and they are trying to put Lightning into that logic. So OmniBolt, which is a Omni plus Lightning, is way better than Omni, because first you still have this scalability problem, but Lightning will move the scalability problem off chain at least once you open the channels. You still have the privacy problem, but Lightning will move the privacy problem off chain at least once you open the channel, and so on and so on. And you still have the Omni scam coin, but it's so down that nobody actually cares anymore. Nobody knows it exists anymore. Nobody uses it, and it's not really necessary to use the OmniBolt features. So it could be a rebranding of Omni that could be of some interest. But I think compared to RGB, it will face the same technical challenges that I will talk about a little bit. The reason why I think RGB is not ready right now to be used by average users is that the on-chain part of RGB is pretty definite as a design, and also pretty complete as an implementation. But the Lightning part, let's say, it has to follow the development of Lightning itself. And Lightning Network itself is in a very, very early stage yet. So there is no simple way to build something on top of Lightning, which is actually easy to do, easy to maintain, and doesn't require an independent Lightning implementation. Just to give you a very quick idea, in RGB, the first idea was to use C-Lightning and create a C-Lightning plugin to do RGB, and then to change and rewrite with the help of Christian Decker a few daemons of C-Lightning. But that turned out to be too complex, and so that route was abandoned because C-Lightning was also evolving a lot and changing a lot. Then we switched on the idea of using Rust Bitcoin library for Lightning, which is Rust Lightning by Matt Corallo and others, which is now LDK. But even there, the situation was that it was on one side not mature enough to stay stable and to be complete, and on the other side not flexible enough to play with it in RGB ways. So eventually the Maxime and the other guys in RGB, they recreated a new implementation of Lightning, which first of all is not finished because creating a new implementation from scratch is slow and expensive and in a way, let's say, wasteful. And also, even when it's finished, the very challenging thing would be to keep it maintained, which would be super hard and in a way also very difficult to do socially and technically and whatever. So basically, there was a new lighting implementation, and OmniBolt has the same problem. You cannot just make an OmniBolt plugin for C-Lightning easily. You cannot do the same with LND. Maybe they can cooperate later on to have LND adopting stuff, but it's very difficult because LND itself is changing very, very fast and adopting new feature every month. And you have all this complication about, people working on Lightning Network are great. I love them. But there is this kind of culture in which you don't have yet a very good solution to the channel backups problem. And yet everybody's experimenting on super Lightning pools with loops and swoops, which is cool. I mean, it's necessary because Lightning is a huge experiment for the future of scalability and privacy in some ways. But still, there is no, from the implementation point of view, you don't even have, if you have a Raspberry Pi with Raspberry Blitz and the backup, you have a good internal backup solution. But if you have to manage manually backup of your Lightning channels on a Raspberry Pi, that's a nightmare right now. Or it's in the other extreme, is very centralized. So long story short, OmniBolt is the same old design of Omni and Counterparty. So you are using global consensus to represent new information that can be reinterpreted as a higher level logics on top of Bitcoin, which is a bad design choice, in my opinion, compared to client-side validation. But it's mitigated by the fact that these logics on top are only used to open OmniBolt channels and to close OmniBolt channels, and most of the actual transaction goes on Lightning itself. But what OmniBolt had to do was to basically create a new non-compatible, non-standard version of Lightning Network. The RGB Lightning Network implementation is unfinished and unstable, but kind of compatible. It could route Bitcoin. You can use it in theory, if it works, to route Bitcoin in the Lightning Network. While this OmniBolt is a very ad hoc solution that will use the Lightning logic to keep USDT on OmniBolt off-chain, which is good because on-chain Omni is not good, but it's not integrated with the existing Lightning network. So the difference is OmniBolt can be probably used faster, developed faster, but then it will be difficult to maintain it long term and to integrate it with the wider Lightning Network ecosystem. While RGB is harder to create in the way we envisioned on Lightning until Lightning stops evolving so fast, but it could be more integrated in the long term. Also because, as I said, OmniBolt only uses Lightning concept on top of Omni in order to avoid writing on chain, while RGB uses Lightning in two different ways. One is creating asset-specific channel that can be used to move channel without writing on chain, but the other is moving around all the off-chain proofs that you need to do on-chain transaction on RGB. So when I give you an RGB asset on-chain, I still use the Lightning Network to send you the payload containing the proof. And I in theory, I would like to use the Lightning Network solutions to the backup problem to backup my RGB data as well, which is something that OmniBolt does not have. Let me finish with this comparison. OmniBolt is probably not better than Ethereum plus Raiden, assuming Raiden could go with ERC20, which I think it can't. But let's say that Ethereum came up with some kind of Lightning Network version that can work with ERC20. That's basically OmniBolt. There is some kind of more connection with Bitcoin because you are using Bitcoin op return, but there is not a huge advantage in using the op return that way. It's just it just creates a conflicts over block space.
Okay, so it generally sounds like RGB might be the better long-term solution there. Could you give me like a quick elevator pitch for RGB, and then I'm going to kind of go into maybe the biggest weaknesses of RGB?
Yeah, elevator pitch is client-side validation, which is what we just discussed, is cool, but there are problems with it. And Lightning Networks already faces and partially, hopefully, solves or will solve the same problems. So RGB can parasite Lightning Network in order to make client-side validation doable. And client-side validation is cool, is faster, more scalable, more private, more whatever, assuming that you can make it work. So this is the base pitch. You can use it for assets when some kind of asset makes sense. This is something I'm not still very sure of. Or you can use it for Bitcoin itself in the future, maybe when we find a nice two-way peg solution.
And then what would you say are the biggest weaknesses of the RGB idea or anything related to it?
So the bigger weaknesses are, one, use cases. The use cases for Bitcoin, as I said, require this kind of weird two-way peg scenarios. And the use cases for tokens requires the necessity for tokens, which I'm not that sure really exists or exists long-term at equilibrium. So probably RGB could be a beautiful solution to an eventually non-existing problem, which is a pretty huge weakness. And the second weakness is the reason RGB is cool is that it can leverage Lightning solutions to client-side validations problems, but Lightning is still far away from really solving those stuff at scale in a sustainable way, in a stable way. So I may say that RGB, I was probably over optimistic of Lightning reaching a stable level before you can use it as an infrastructure to build stuff on top. Is still very, very hard. It doesn't mean it cannot be done. I mean, people made stuff like beautiful stuff like Sphinx Chat or stuff like WhatsApp or other stuff on Lightning. So it can be done, but it's really, really hard to do. And so, yeah, I think these are the two things. RGB is super Lightning network dependent in order to be done in the way you want it to be done. And the first one is RGB requires a use case for assets. I mean, if in a future where you don't have USDT anymore, and in which CryptoKitties can be, they can be exchanged on a decentralized network, but you can also exchange them on a centralized network. It doesn't really matter. So in that kind of scenario, there may be a solution without a problem anymore if you don't have any kind of legit asset to move around. There is a third weakness to RGB, which is not really a weakness, but it's a danger. RGB is pretty general. As I said at the beginning, when you understand the concept, you can use the concept of a single-use seal to not just prevent double spending, but also to create this kind of state machine, smart contract engine. I understand why people could get excited about that, and that can be a very that can be like addictive tunnel if you enter it, because you will always try to generalize. I mean, it's not a simple tool that can be used only one way, so you get your job done quickly. It's something that can be explored to do. If you look at the RGB chat, there is people just asking when USDT, which is in my opinion, is the pragmatic question to ask. But there's also people asking for crazy kind of smart contracts on RGB, which is in theory possible, but it opens up a Pandora's box of cool but very, very complex stuff.
Bringing up Tether again, people are saying that they're looking forward to that use case potentially. I'm struggling to give a shit, I think, on my end, to be entirely honest. Tether's been around for a while. It's probably one of the most liquid cryptocurrencies right now, just because so many people are using it across all the different shitcoin chains. Like, I don't think Omni and Bitcoin is being used almost at all anymore. Let's say RGB ends up coming out and does what it says so on the label, etc. And, Tether comes to RGB, comes to Bitcoin again, woohoo. Is anyone going to give a shit? Like, are we going to have to fight this battle of okay, we got everyone on board of Lightning. Now to get everyone onboarded onto RGB, is that going to be a worthwhile battle to fight just to get fucking Tether on Bitcoin again? Like, it just seems like I don't care, man.
I understand your point, and I'm not sure that the answer is yes in the typical crusade tone that I may use for other issues. So the reason for me Tether makes sense is that they can decouple two functions of a typical exchange. So the typical flow that I see as important right now is a flow from fiat to satoshis, from USD to sats. This is the flow I'm interested in. And in this flow, you have two functions. First, you have to move fiat to the exchange, and the exchange now owes you some fiat, and they can represent it digitally in the account of the exchange, the amount of fiat-based credit that you charged, that you filled the exchange account with. And that's the first function. And then there is the function of trading, where you do like bid and ask. You have supply and demand of sats priced in dollars. You have withdrawals of Bitcoin, deposits of Bitcoin. You have leverage. Maybe you have this crazy stuff. So the typical centralized exchange like Bitfinex, since we are talking about Tether, it does both the functions. You give fiat to Bitfinex with a wire transfer or whatever to a bank, and now they represent a fiat credit to you. And now you do trading, basically. You exchange back, you move around, and you do it in the same platform. While with Tether, Tether basically decouples this function, and it keeps the first function. You give some wire transfer to Tether. You do KYC, AML bullshit, everything you have to do, because otherwise they will just come and take Tether down as a company. So because it's centralized, so you do the KYC bullshit, but now you have the representation and all the trading and exchanging and whatever between this fiat credit and actual Bitcoins can happen potentially elsewhere. You can do it inside Tether, but it can happen elsewhere, even in atomic swap, even on liquid atomic swap, or tomorrow even on RGB atomic swap, and etc. etc. This is potentially very cool, but right now the limitation is that in the typical standards that are used by Tether to do this, not for Tether's fault, but just because it's the only stuff they have. You have ERC20, and previously you had Omni. Now you have Omni and ERC20 and Tron and whatever. These infrastructures, they are super bad at fungibility, super bad. You can track down the creation of a Tether, USD Tether, and you can track down everything else, and you can blacklist stuff, and the regulator can ask Tether to blacklist the Tether account, the Omni address of Julian Assange or whatever. While in RGB, they couldn't, because the idea of RGB is that you issue a USD Tether on RGB, I give it to you. Now I don't know if you spend it or not, or where it is, who has it, how many transactions on chain or off chain he went through. I don't know anything. And when somebody will give me that USD Tether back, I will know that this USD Tether is giving me back is valid, is true, is not double spent, is not inflated, but I will not know his past history, because what we do is we use a confidential transaction inside confidential assets technology inside the past history of the asset. So Tether can be required to do KYC in the issuance because they have no other option than to comply with this bullshit. And then everything can happen in the secondary market, and then somebody can come back to Tether to redeem the dollar, and Tether can ask this somebody to be KYC or AML bullshit compliant, but they cannot ask him, they cannot blacklist him because somewhere in the process Julian Assange participated to some kind of atomic swap. They don't know, they cannot even see it. So this is my opinion, an even more exciting reason to want to see Tether on RGB than just so it's on top of Bitcoin. Sure, removing legitimacy from shitcoins is something that I would consider good, because I consider shitcoins, as you know, as everybody knows, I consider them a distraction in the best case scenario, and a danger to newcomers, and a waste of time, money, and reputation, especially for newcomers in the worst case scenario. But if the only thing that Tether on RGB did was just to remove a possible legitimacy for the shitcoins that Tether is using right now, yeah, cool, but nothing to be so excited about. But the idea that they can use it to really decouple, really disentangle the issuance and redeeming part, which will be heavily regulated because they have no other choice, because it's a centralized part, with the trading and transaction part that can be completely obfuscated by RGB, that will be really, really cool. Of course, we discussed this stuff with Tether people many times. For them, is a very brave move to sponsor this technology and this idea, but it's not only good for them, it's also a danger for them, because if they tell to the regulator they cannot blacklist Tether on RGB based on previous owners, then the regulator can just tell them, one, don't use RGB, so all the effort is wasted, or two, don't issue USDT anymore, because now the market standard for tokens is RGB and you cannot blacklist, and so now you have to close down. So they are super, in a way, super brave to go down this path, because it's a path that gives the market more freedom. So it also gives Tether more liquidity in the secondary market, but also gives the Tether company a lot of legal and compliance challenges more. So maybe ultimately it turns out that RGB either it's too difficult to make work properly, so they will not use it because they are pragmatic, then they will just use something else instead that works today, or it works so well that they cannot use it for Tether. So I will not push it. I'm super happy to be super honest. The reason I would like to see it is that because we discussed that so much, that after 3 years not seeing USDT on RGB will feel like vaporware, that like we promoted vaporware. And in a way, I mean, we promoted an idea that it would be cool to see in production. If it doesn't happen, I mean, that's fine, and it's okay.
So we're kind of reaching towards the end of our time here, but I wanted to try to make sure we got as much in about RGB as possible here. So I wanted to ask some lightning questions, but before we did that, was there anything on RGB that I missed? It's like there's very detailed stuff here, but I just wanted to make sure if there was anything else that you just wanted to get out there for the listeners to know about.
Just one thing. I was one of the main designers of the idea and promoters of the idea a few years ago. Right now, I'm not a developer. In general, I'm not a good developer and not a developer. Everything that you can hear, which is cool about RGB, is not my merit. Is not due to me. It's due to other people actually writing code, because I mostly don't. And everything which is bad on RGB is my responsibility, because I cooperate with the initial design. So there are two things. There is my idea, my obsession with client-side validation RGB, which I still kind of push as an intellectual challenge. And then there is the RGB repository operated by Maxime and other people. They may take completely different direction from what I'm discussing today. They are not responsible for whatever I can say now that they disagree with. So they're completely separated things that I don't want. This is not my project. It's not my startup. It's one of the several. Yeah, probably the last thing I want to say is RGB is not my main focus in the last years. It may seem so because it was one of the projects I tried to help that managed to have more exposition to the press, for example, because there were tokens involved. So people were like, oh, are you going to do tokens? So there was a lot of attention, but RGB was just one of the several open source standards that we tried to help. At the beginning, my effort was to try to help open timestamps, then to try to help Peter Todd developing Proof Marshall. Then actually, I gave a very, very little logistical contribution to the beginning of the Bolt specification idea. And then after that, I gave a more substantial contribution to the organization and fund distribution and fund funneling of BDK, especially the fusion between Magical Bitcoin Library and BDK. So What I'm doing on RGB, I'm doing on a few other Bitcoin open source projects. RGB got more publicity because it's asset related, but there are a lot of stuff like there's the idea of Storm, which is basically also developed by Maxim Orlovsky, which is basically decentralized storage with Lightning payment. There's the idea of Lightspeed, which is like a partially trusted Lightning on top of Lightning. So there is a lot of stuff that we try to help promote, sponsor, or funnel money to, together with the usual partners like Fulgur Ventures, and which, or by the way, and Bitfinex, of course. Fulgur Venture are also sponsoring very cool stuff about DLC that I'm also looking into. So there is a lot of stuff going around beyond RGB. I'm not the RGB guy. I'm not doing that as a job. So just to clarify this.
Thank you. Well, so what have you been doing more so if it's not RGB?
So my main job is to do consulting to, let's say, fiat clients, mostly in Switzerland, but also elsewhere in Eastern Europe, a little bit, and elsewhere. And these are basically banks or other kind of companies that want to sell Bitcoin to their clients, or buy Bitcoin in behalf of their clients, or store Bitcoin in behalf of their clients and securely. So I just do consulting, which is the base level. On top of that, since I was exposed to these clients, for example, a Zurich client, they wanted to try RGB. So I said, let's not pay me as a consultant to do something which should be an open standard. Let's donate some of your money to this association that will sponsor RGB. And I did the same with Magical, that then became BDK with CryptoSquare and others, still under Alekos Fellini's direction. And I did the same with Peter and Proof Marshall, with a few of my clients donating to Proof Marshall for a few months to boost that. So what I do is I do consultancy, and then I ask my clients to donate money for a few selected spectrum of open source Bitcoin related projects. I try to do something which is in a way similar to what in a more structured way Blockchain Commons by Christopher Allen are doing, or other collectors of good practices and standards are doing, or donation managers like Brink or whatever. When I did try to do something more structured, that was the idea of the BE Foundation, it didn't go so well with the community, so I stopped. And now I do that on a very personal and disorganized and random base. I'm trying to stop doing consultancy, and I try to move from consultancy to retail education. So not banks, but just people doing courses and seminars and workshops. I'm still struggling with that, because that means that I have to be in charge of organization of staff and date, and I'm very bad at that. So we will see.
So it sounds like there might be a little bit of crossover between you and I there. I definitely consider the podcast to be an educational thing. Maybe not on the same level as a seminar. As we're closing up the podcast here, like we might not actually get to your general opinions on Lightning on this episode. I might just take it in a different direction and, focus on what maybe the listeners could take away. So in your opinion, what do you think people could do to kind of explore RGB more? And we'll kind of take it from there.
For RGB, just try to use it. Try to use it on chain, which at this point should be reasonably easy. You download a few, basically there is the RGB node that will work with command line and a few manual stuff. So you have to build the transaction manually. So it's kind of difficult, but then it can also work with a few, like with a product by Pandora's core company, which is called MyCitadel, which it's a wallet which is also using RGB, and maybe in the future other wallets will also expose this kind of easy to use interface to try to play with assets. I'm often talking with the guy of Exa wallet, and also other wallets are interested in that. So you just try to use the RGB node, which is a little bit more complex, or try to use some of the wallets implementing RGB on chain, which is easier. And then if you want to experiment with RGB on Lightning in a complete sense, RGB is always on Lightning. But if you want to go on Lightning channels, then you have to try to download it and make it work, but it's still work in progress after many years, and it's still very, very difficult to have it working completely. So maybe instead of just trying out, in that case, you should actually try to understand how to complete it together with the current developers.
Right. So if any developers are out there and you're feeling like you want to try to get RGB to completion, this might be a project to help out on.
Yeah. Well, especially very quick comment. In order to make RGB work on Lightning, the choice of Maxime was to create a new Lightning implementation from scratch. So this could be interesting in general for other kind of stuff, because if you have another Lightning implementation and you want to try to implement the RGB concept on yours, maybe let's try. If you want to try to complete the LDK implementation in order to get to a point where it can be used to actually create a Lightning wallet in real life in a reasonable amount of time, let's do that. If you want to put some new stuff on top of the Lightning Network implementation used for RGB, which is completely independent and orthogonal to RGB, please feel free to do that, because there is a new Lightning implementation to play with. So there is a lot of stuff you can do.
Maybe my final call to action for our listeners here. People wanting to get into Lightning, maybe not into RGB specifically, but maybe just Lightning in general, or maybe into Bitcoin in general. Do you have any thoughts or ideas on how they could step their foot in if they're, totally green and totally new to this whole space?
Well, I think the usual progression would be first try. So you try to use just to understand. So you can try with semi-centralized solution like Phoenix, which are super simple, or you can use like Breeze or Moon, which are also a little bit centralized in some way, but very simple to use. And then you evolve from that into not just trying, but also not just using, but also running. So you run a few nodes. You try to set up your Lightning node, maybe with a guide initially with a Raspberry Bolt, or you just try to recreate Raspberry Blitz or MyNode or Umbrella or whatever. And then you run the node and you run the channels and you try to see liquidity and loop and stuff like that. And then after that, you try to understand, before working on the protocol itself, the third step after using and running will be giving feedback. You understand what works and what doesn't work, and especially you document and you explain to developers what doesn't work for you and how it doesn't work. You send error messages, you send the PRs, you send support requests. This can be seen as an hassle, but is actually useful. That this makes developer understand what doesn't work. Then, as another part, you can, which is something more difficult, which is the fourth step, you could try to not just to signal what doesn't work and to alert for bugs or limitations, but you can document what works. So you can create your own guide or meta guide, selecting from various guides in order to use Lightning. You can create your blog post about Lightning liquidity management. You just leave information about what works and how it works. And then the other step is you build tools first. You try to build maybe a new backup solution. You try to build a new backup stuff for Lightning, a new interface. Try to cooperate with tool builders more than protocol builders. And then when you're confident, because most of the things which are missing from Lightning are now are not. Yeah, there are a lot of stuff to do in the protocol, like Eltoo, and then using elliptic curve points instead of hashes for the routing HTLC part. There is a lot of cool stuff you can do there. But even without touching the protocol, you can do better tools, and tools are still very early stage. And of course, you have like the heavy players like Lightning Labs and Eclair and Async and Blockstream, and they are doing their stuff, and now LDK, but they all have some kind of priorities, product derived priorities, and maybe you have other priorities and other people have other priorities. So I will focus on the tools first, and then when you really feel you are like a wizard, you start bothering people trying to work on L2 and actual protocol changes, which are the hard stuff to do.
So I love that answer. I thought of one more question here at the end. Would you say that you're more bullish on RGB or Lightning Network itself?
Definitely Lightning Network itself so far. RGB is cool, especially because it represents this concept. I'm sorry if I'm repetitive, but this client-side validated concept is I think it is what Bitcoin should have been if it was realistically doable back then to manage all the complexity of client-side validation. But global consensus is very, very bad, is very, very limited, is very, very problematic. So RGB is a great idea. I find it exciting to explore this client-side validation world, but Bitcoin can survive without it. While I think that Bitcoin, it can survive without Lightning using trust-based second layers like Alfine style, but it will be a very, at this point that we tried and we tasted what a trustless second layer will be, it will be a pity to have just the first layer and then to go in a trusted solutions, which are more fragile. So I think that Bitcoin really needs Lightning. Indeed, I'm obsessed with this LMPBP definition of the stack. It's like with the internet protocol itself, you don't have enough to create direct connection. You need at least TCP over IP. And then there is a lot of stuff over TCP like HTTP. And I think with Bitcoin is the same. BP, so the Bitcoin protocol base layer, is cool. It gives the name to the entire protocol stack, but it's not sufficient per se if you don't create on top the equivalent of TCP, which is LNP, the Lightning Network Protocol. And then on top of that, you can have several added layers and at increasing complexity and increasing abstractions. But I think that LMPBP protocol stack needs at least the LNP part, the Lightning Network part.
Got it. Well, I think that's the end of the podcast there. Do you want to let people know how they can find you on the interwebs?
Yeah, they can find me on my website, which doesn't work at the moment since probably 3 weeks, which is giacomozucco.com. I'm using BTC Pay server and I messed up with Let's Encrypt somehow. I still don't know how. So I will try to fix it this weekend or the next weekend. I don't know when I have time. So if giacomozucco.com doesn't work when this podcast comes out, just find me on Twitter as always, because I will be there trolling and shit posting as always.
Well, I really appreciate you joining me on the Lightning Junkies podcast, Giacomo.
My pleasure. See you soon.
See you next time. Boom. That was the 44th episode of the Lightning Junkies podcast. I really hope you learned something from that particular episode. And on the topic of learning, we here at Lightning Junkies are very interested to know what you might want to learn, what gets you excited in the world of Bitcoin and Bitcoin Lightning. We want to explore more of that. We want to create more content that might be up your alley. You can slide into our DMs on Twitter at LNJunkies. Let us know what you want to learn and what gets you excited. Don't forget, you can support the podcast on Breeze, on Sphinx Chat, at lightningjunkies.net/support, as well as store.lightningjunkies.net. Okay, junkies, that's the end of the episode. What are you doing? Get out of here. I'll see you on the Lightning Network.